Hi there, welcome back to this series on end-to-end machine learning with SageMaker. Whether you are a data scientist or an ML engineer or a solutions architect or someone just looking to understand how machine learning gets deployed in the real world, this series is designed for you. In this series, we are going to walk through what it truly means to take an ML project from idea to impact. That means not just building a model in a notebook, but turning it into something that can be deployed in a production, which can be scaled, which can be monitored, and we'll do all this using Amazon SageMaker, one of the most powerful platforms available for managing the full machine learning lifecycle from data preparation and feature engineering and training and hyperparameter tuning to deployment and model monitoring. SageMaker has got tool for every step and we are going to cover them all in this series. So each session will have a conceptual part where I'll walk you through what is that concept behind this particular step, and then end of that session we'll have a hands-on demo of using that particular, like if I'm doing data preparation, how I can do the data preparation using the SageMaker, how we can train the model using SageMaker, how we can monitor using SageMaker. So we'll use all these things using a live demo. So by the end, you just not know how SageMaker works, but you will know how to build production grade ML systems on it. So with that, let's get started. So before we dive deeper, let me give you a quick overview of what this course covers and how we'll progress from a business problem to a production grade machine learning solution using AWS SageMaker. In session 1 is about business use case to ML problem. We'll start by identifying a real business challenge and learn how to frame it as a machine learning problem. We'll talk about the stakeholders, the impact, and what success looks like in a business terms. In session 2, we'll do the data preparation and feature engineering. In this session, we'll clean, transform, and enrich it to make an ML ready. Feature engineering is critical, is often makes or breaks your model performance. In session 3, we will do the modeling and training. Here, we select the right algorithm and train our model. We'll walk through the SageMaker training options, whether you are training from scratch or fine-tuning a pre-built model, and track our experiments as we go. In the session 4, we'll do the model evaluation. After training, it's time to evaluate a model. We'll analyze the model performance using metrics like accuracy, precision, recall, and confusion metrics, and we align model performance with the business goals we defined earlier. We will also see a demo of SageMaker clarify to understand how a particular decision has been reached by the model, what features it has used, what features has actually impacted to reach the decision. In the session 5, we'll talk about deployment. Once we are happy with the model, we'll deploy it to productions. We'll look at the SageMaker endpoints. We'll look at the how we can actually deploy the model to the SageMaker endpoint in a safe and a scalable manner. And then finally in the last session, we talk about the monitoring part. We'll close the loop with the model monitoring. So we'll see what is the model monitoring means, how detect the data drift, what is the monitoring real world performance means, and to ensure that model remains reliable and accurate over time. So by end of this course, you will understand not just how to build the models, but how to take them all the way to production in a way that aligns with the real business needs. So before we jump into machine learning, let me introduce to our fictitious company called TelNova. So TelNova is a mid-sized telecom provider operating in the US, offering mobile plans, high-speed internet, and bundle services packages for both residential and business customers. The company has got a carved out a plan which is a competitive pricing, but despite that, it's been steadily losing market share to larger competitors. So the leadership team is increasingly concerned about the customer churn, that is customer cancelling their service and switching to other providers. So they have asked the data team to explore whether machine learning can help them to identify at-risk customers early so they can act before it's too late. So this is a real world problem we'll focus on throughout the course, and we'll talk through how to approach, design and deploy an ML solution to solve it step by step. So this is our customers problem. The challenge they're facing is declining customer retention. There's a 19% customer churn rate, and then it takes 5 times more expensive to acquire new customers, and then 58% customer complaint mention lack of personalization, and then the revenue impact is $4.2 million. This is the impact our customer is having. So now we are going to see how we are going to address these challenges. What is the step-by-step approach we are going to take to address these challenges? So let's start at the beginning, the business problem. So for TelNova, the key challenge is customer churn. Customers are leaving and leadership want to know who is leaving, why are they leaving, and when are they likely to leave. So that the question we are going to solve is that when are they likely to leave, right? This is a what question we are going to focus more. We are going to see whether we can use a machine learning to predict if a customer is leaving or not. So now let's talk about the scale of this problem. So TelNova customer churn rate rose from 12% to 19% just in 1 year. That might not seem dramatic at first glance, but for a telecom company, that kind of increase translates into millions of dollars in lost revenue and serious concerns about long-term sustainability of their business model. So there is a strong business case for solving churn. Retaining a customer typically costs 5 to 7 times less than acquiring a new one. So if you can reduce the churn even slightly, the impact on revenue and customers' lifetime value is significant. The goal here is to leverage data and AI to reverse this trend of customers leaving. So how do we do that? Through a data-driven approach. If you can use historical customer data to identify at-risk customers, that means the customers who are leaving early, we can proactively launch a retention campaign like sending a discount coupon or changing their plan or maybe calling to check in. The earlier we identify the risk, the better the outcome. So as a first step, we try to map the stakeholders and their goals. So overall stakeholder, we are having a CEO who is concerned about the business growth, reduce churn, competitive edge. We have a CFO, he is looking for a cost of solutions versus projected retention gains, marketing directors, data team, privacy and security team, customer support team. So even before you solve your machine learning problem, even before you try to define the NML problem, first understand the step one we identified what is the business use case, what is the challenge the customer is having, and then the step two is who are my stakeholders and what are their interests, right? What are their goals? It is very key to identify so that these two will guide you in throughout the process. Whether you are making a decision, okay, whether even if you want to make a technical decision, whether what model to use, what what type of whether I want to focus on precision, I want to focus on recall, whether what accuracy I want, all those things will actually guide, because we know that what I'm trying to achieve, what I'm trying to focus, what is the outcome of this particular decision I'm making, this whole ML journey is going to impact my stakeholders, how it is aligned to their goals. So now that we have defined TelNova's business problem, customer churn, we need to decide if machine learning is a right solution, and if so, how to approach it. There are 4 key lenses we use to evaluate this. First, we start with the business problem fit. Does this problem have a pattern that ML can detect? Not everything can be done by machine learning. So for churn, the answer is yes. We have a historical data and a clear behavioral signals that, like usage drops or complaints or billing delays or the plan they are using, can help us to predict the churn. Plus, the ability to predict churn is highly valuable to the business. It allows a targeted interventions, like that this customer is leaving, I can run a specific campaign for set of customers who are actually leaving, right? Second, we think about the learning approaches. We are going to talk more about this coming slides. What it means is that do we have a labeled data, like who is churned and who didn't? then we can use a supervised learning. Or are we just exploring customer pattern? Then we can use unsupervised learning, like clustering might be better. So in TelNova case, we do have a labeled customer data which tells which customer has left in the last 1 year, and we have all the information about that particular customer. So which points us towards a supervised learning for prediction, and possibly unsupervised learning for maybe for customer segmentation, to segment my customers into high value customers or medium value customers or low value customers, or maybe on different demography, different geography. If you want to segment customer, then also I can use my unsupervised learning. Third, we consider the prediction type. There are different prediction type. I'm going to talk more about this in the coming slides. Number one is that classification helps us to predict who will churn. For example, is this customer is going to predict or yes or no. Then another type of prediction type is classification, that can help to estimate when a customer might churn, right? And a clustering can help us to find a natural group, like whether casual versus heavy users, which can enhance the personalization or retention strategy. So let's start with one of the most widely used approaches in the machine learning, which is supervised learning. In supervised learning, the model is trained on historical data where both the input and the current output are known. So we have a labeled data. So for example, in case of our TelNova, we might have a data on customer usage, their plan type, and how many times they call the support. That's our input features. And we also know whether or not those customers are churned. That's our output features or labels. The goal of the supervised learning is for the model to learn the patterns in that maps the input to the correct output. So it looks at thousands of examples and figures out what conditions usually lead to a customer leaving. Once trained, the model can make the predictions on new customers who haven't churned yet and tell us how likely they are to churn based on their current behavior. So think of supervised learning like a student preparing for a test by studying past exam papers that already have answer keys, right? The student learns by seeing the questions and their correct answers, and over time they understand how to solve similar problems on their own. In the same way, the machine learning model uses labeled examples to learn how to predict the future outcome. So let's see some of the real world examples of supervised learning. Something like a spam email detection, or maybe credit risk scoring, customer churn prediction, housing by prediction. These are all the supervised learning because you already have input features, you have a labeled data, you know what is the outcome of that particular data, and you can use that data for your supervised learning. So far we talked about the supervised learning, where the model learns from labeled data. Now let's look at the opposite approach, which is unsupervised learning. In unsupervised learning, there are no labels, no right or wrong answers. The model is only given input data and it has to find the patterns on its own. Think of is giving a model a big pile of a mixed puzzle pieces, but without the picture on the box, right? So there are no answer keys, no predefined categories. The model job is to figure out which pieces look like they belong together. That's exactly what these algorithms do. They discover the hidden structure in the data by grouping similar items. So let's break it down further. So say the model receives the raw input data. For example, customer usage records. It has no idea who churned, who stayed, or what action were taken. It tried to organize the data based on similarities, like grouping customers by behavior or identifying unusual activity that might signal fraud. We call this self-discovery process, and it is useful when we want to explore the data, find segments, or detect anomalies. So again, the best way to remember this is supervised learning is like practicing with answer keys. Unsupervised learning is like figuring out the rule of puzzles as you go. Both are powerful. It just depends on the problem we are assigned to solve and data we have available. So typical examples of unsupervised learning is customer segmentation, where it groups based on behavior, and we have product recommendations like which you see in Amazon or Netflix, anomaly detection like fraud detection, whether and then systems failures or any topic modeling common themes in a document. These are all the real world examples of unsupervised learning where the data is not labeled but model learns on its own based on the structure of the data or the patterns in the data. So far, we have talked about how machine learning learns, right? Whether it is a supervised using a labeled data or unsupervised using unlabeled data. So it's time to focus on what they predict. So different ML problems require different types of predictions, and each one comes with its own modeling techniques and evaluation metrics. So let's start with the classification. This is a one type of prediction that assigns inputs to a predefined categories or labels like yes or no. Right? A common example is whether a customer will churn or not. Right? It's a great problem where we want a clear decision between options. Next is regression. This is used when the output is a continuous number. For example, you are predicting a house price, a customer monthly bill, or expected data usage for your plan. It doesn't give us a category but rather a value on a scale. Then we have a forecasting, a special type of a regression that deals with the time-based data. So it answers questions like what will customer count look like in next month? How much revenue will we generate next month? How much inventory I require in my store in the coming weeks or months? So these models rely heavily on patterns in the historical trends. Finally, there's a clustering which falls under unsupervised learning. So instead of predicting an exact label or number, clustering groups similar items together like segmenting customers by behavior. The goal isn't to predict a specific value but to reveal hidden groupings that helps with target or personalization. So to summarize, the type of prediction you need to make, either a classification, regression, forecasting or clustering, determines everything. The algorithm you use, how you evaluate your success, how you prepare your data, this determines everything. So one of the important steps in your machine learning problem is you need to know like what type of prediction you want to do, in what category this prediction falls. So for in our case, we are going to do a classification where we want to predict whether the customer is churning yes or no. Now that we have explored different machine learning approaches and prediction types, let's bring it all together and apply it to our case at TelNova. First, the business problem what we discussed in the first slide is that too many customers are leaving, right? So today customer churn rate has jumped significantly and leadership team wants to understand who is likely to churn next before it happens. So what is the goal? It's simple. Identify customers at risk of churn so we can retain them proactively. So this isn't about just prediction, it's about enabling the business to act on those predictions in a meaningful way. So now let's move into frame our ML problem. So we know the business problem. Now how do we frame our ML problem? So we have access to historical data, things like customer usage patterns, support calls, building activity and tenure. And we already know the outcomes of those data, whether they churned yes or no. We know which customers left, which customers stayed back. This means we can train the machine learning model to learn the patterns that typically lead to churn. In other words, this is a great candidate for a supervised learning approach. Finally, we define in the technical terms, the model input will be features like the behavior and customer profile data. The output will be churn label, either customer churn or they didn't. And this sets up to build a classification model that can score a new customer based on a churn risk. And from there, business teams can take a target action. So once the model is trained, what exactly the output looks like? The output is a probability score, a number between 0 and 1 that tells us how likely a customer is to churn. For example, if the model outputs 0.92, that means there is a 92% chance that they are going to leave soon. But this score is only useful if you take a business action based on it. So we might have, for high risk customers, we might trigger a retention campaign like discounts or loyalty programs. Or for medium risk customers, maybe a simple check-in call or satisfaction survey enough. And for low risk customer, we might decide to take no action and save those resources for high risk segments. This is a business value. We are able to predict a customer is going to leave yes or no. Then I can allocate my resources only where it truly matters. So that brings us to the end of session number 1, where we discussed about the business challenge the TelNova customer is having. And we also discussed about the different types of learning like supervised learning, unsupervised learning. We discussed about different prediction types like classification, regression, clustering, forecasting. We also framed our ML problem. We are taking a business problem and framed an ML problem from that business problem. And our next task is going to be to data preparation and feature engineering.